Welcome everybody, welcome to Tableau Conference and the first day of Tableau Conference. And welcome to this session, introduction, or at least lots of fun with LODs, an introduction. So this session, as Benoît already said a little bit, is about how do LODs actually work, what are LODs, we're saying all these sorts of abbreviations, level of detail, what does level of detail mean, how do we use those in calculations, and what new realm of calculations can they open up in your Tableau dashboards. Now we're Benoît and Erwin, and we'll explain a little bit who we are later on and introduce ourselves. But that's basically what we said, right? The session's intermediate. If you've never worked with LODs, welcome. Welcome to the wonderful world of LODs. If you've worked with them a little bit but just want to know what they do under the covers, hopefully you'll still see some, get something from today's session. And hopefully we can get a little bit of cool examples in here today as well. As it is an intermediate or a starting session, sort of like just open up those covers, what do LODs actually do? We fooled you by getting you in by saying lots of fun with LODs, but we do have to explain it, of course, so if you feel cheated on that at the end of the session, that's fine, but we'll do our best to keep it lighthearted. So that's the agenda for today. We're going to talk about level of what, right? What does detail even mean in the world of Tableau? The types of level of detail calculations that we have, how does that impact the order of operations of everything that Tableau does? Hopefully we'll get to some useful examples, and we'll definitely make sure that there's Q&A at the end of the session. So there's quite a lot for us to go through, so if you have questions, we do ask you to hold on to those to the end of the session, and then we'll make sure that we have time to answer them. Session's recorded. Feel free to take all the notes you want, but you can always look this content back. It should be live on YouTube on Monday. You'll also have the slides to your disposal. So take all the notes you want, but if you just want to sit back, feel free to do so as well. And with that, let's get started.
Let me make sure everybody can hear me. Good morning, everybody. My name is Benoît. I am French. I happen to like cheese and wine and bread. Yes, that's true. I'm also the happy father of 2 young boys. I'm really happy about that. Otherwise, I am a bit of a blockchain enthusiast. Before I joined Tableau, I worked first for the competition, then a partner, and now finally at Tableau. Very happy to be here. And today I am also very lucky to be here with my excellent colleague Erwin.
Thank you, Benoît. My name's Erwin van Laar. I am a product consultant here at Tableau's London office. Basically means that helping people see and understand their data is the top line in my contract. That's what we do. By looking at me, you probably have already seen that I do like my food a little bit. Maybe overindulge occasionally. We just had Taste of London, which was great. Background's actually healthcare and management, so it wasn't even tech. It wasn't until I was a customer of Tableau that I thought this is amazing. Upended my world, worked for Tableau, moved to London, been here for a year and a half now, never looked back. For those of you in the room, I am Dutch, I don't have weed on me, so don't have those questions later on during data night out. I'm not your guy. So just so we're all clear, right? I mean, it's all about making sure we're all on the same level. So let's talk about level of detail. What does level of detail actually mean? Now, first of all, that means we have to talk about what the level of the detail of the data actually is. So the first thing that we all need to know if we start doing calculations in particular, but just dashboard design in general, is what is the level of detail of the data. I'm going to move to you guys a little bit as well. I don't want to be standing over there all the time. So first of all, we need to know what the data actually represents, so we can do our calculations and know when they are valid to do so. So throughout today's session, we didn't want to clog your minds with new data sets. So we're going to use Superstore, which is that free data set that always comes with Tableau. Who's never used Superstore before? Show of hands. Beautiful. So we all use those, almost everyone. For those of you who don't, or just explain another time, each row of the data represents a transaction. But that transaction can be a transaction within an order. So multiple rows can make up an order. So it's on the product level, not on the order level, which is important for us to know how we do our calculations. We all know Tableau aggregates, sum of sales, throughout all sorts of dimensions. But we need to know, first of all, what's just the level of detail of our underlying data. When we then start building dashboards, we start aggregating them up, but bringing down the level of detail. So this is where the level of detail of the viz comes in. So as we're looking at the screenshot here, we're looking at, for instance, just regular example, sum of profit, and we're splitting that out by region. So the level of detail is determined by the number of dimensions, usually those discrete blue pills that you can see, that we bring into the view. And the more domains that are in one of those dimensions, the higher the cardinality of that field, the lower the level of detail that becomes. So you have more countries, therefore you have more marks. That determines the amount of marks that you have in your view. And you can use one dimension, or you can do combinations of those. We can now see region and country. They're of course part of a natural hierarchy, but you can start creating all these combinations. And all those combinations create a lower level of detail every single time, all the way down to the row level data, which is then the level of detail of the data. Everyone's still on me with that one, right? Great. So if we talk about the level of detail of the viz, and we're looking at what is the actual granularity or the level of the detail of this viz, which dimensions did I bring into this view? Yeah, and segment. Yeah, absolutely. So the granularity of this viz is not just what's on the rows, it's also what's on some of those marks, because they do split up that mark into particular constituents, right? Every bar still has 3 individual constituents for each individual segment. So if I break up one, so I'll just highlight this blue bar. What does that blue bar tell me? That's the sum of sales for? And consumer. Yeah, absolutely. So that is indeed office supplies, binders, and consumer. So when we're talking about what are then the elements within the viz, or the shelves that we put elements onto in the viz that define the level of detail of the visualization before we start talking about what the calculation then does. It's actually almost everything. First of all, everything you drag into the view onto your rows or your columns already defines sort of like how you split up your view. But also the marks that say color, size, text, and detail do split up the level of detail because they add different layers of dimensionality to the view. Whether they add color or just, if I were to, in the previous slide, were just to add segment to detail, I wouldn't see those 3 individual colors. I will just see that bar broken up into those 3 individual elements. So what are then the shelves that don't affect the level of the detail of the viz? And it's actually just these 2. Filters don't affect the level of the detail of the viz. They just take data out of it before we start building that particular view. And then in the tooltip, that's just the pop-up message that we have there. So that doesn't impact the level of the detail of the viz. So now that we got all those basics out of the way, what are then level of detail calculations and how do we write them and why are they so powerful? When we drag a pill or a calculation onto a view in Tableau, we can see something like the average sales. But we never specify on which level we want Tableau to calculate that. That's determined by the level of detail of the visualization, whichever dimensions you brought into the view. And that's where the level of detail calculations differ. Because instead of writing just average of sales, we start bringing in the dimension that we want that calculation to run on, specifically within the calculation itself. That's where the power lies. So when we talk about level of detail calculations and how we write them just purely from a grammatical point of view, they have 3 elements and we have 3 types of level of detail calculations. And we'll go through all 3 of them in this session. So the first part is the keyword, and we have our fixed, include, and exclude calculations. Once again, we'll pull them apart later on. The next part is the dimensionality, and it's actually that dimension we're bringing in. You can see this as your scoping keyword. So the scope you want Tableau to run that calculation upon, that's what you bring in here. And it can be one, it can be multiple. You can even bring it in on a year or a monthly basis within the pill using date truncations. You can make them as complex as you want. And then at the end, there's always an aggregation. So sum of sales or whatever you want to put in it, but it always needs to be an aggregate. Now then we wrap those into curly brackets, and we just do that to keep it legible. Level of detail calculations, when you get really professional can get really hairy. They can get nested. Your sum of sales might not be a sum of sales. It might be a truncated or a min minus max or if-then statement, which results is still an aggregate. So it can get really messy, really cool in its use case, but very messy. So that's why we just wrap it in those curly brackets to sort of like make sure that we continue to understand that. So that's just the layout of that calculation. So let's just start talking about that first one, which is fixed.
Thank you, Erwin. Okay, let's take an example. Okay. I won't need this. Okay. So if we have a viz with 2 dimensions, segment and category, and we write a fixed level of detail expression on the category. That, for the sum of cell, that will give us the sum of cell per category, obviously, and it will not take into account the segment, right? One thing that's very important if you use a fixed level of detail expression is that it's calculated completely independently from the level of detail of the visual. And we'll see an example of that in a minute. But that's the one thing for a fixed level of detail that you should remember. It's completely independent from whatever you put in the viz. So if we take an example, again, segment and category, we have 6 unique marks. But if we calculated the sum of cell only at category level, and then there's only 4 categories, we'll have a result for each of these categories. And this value will then be replicated on all of the other categories. So you see, for instance, for the category, the red category, 5 gets replicated on the different segments. And so on. For those of you who are familiar with SQL, that's personally when I understood level of detail expression. That's the equivalent of a group by clause in a SQL statement. So if we had the fixed on category of the sum of cells, that's equivalent to a select sum of cells group by category, right? This happens behind the scenes when you bring visual dimensions into a viz. There's also a group by, but if you needed to look at a calculation independently from the viz, this is how it would work. Now let's take an example of that. So we're looking at a few customers. They've made different orders. Each order has multiple line items. And the question that we ask ourselves is, how many customers are profitable? So maybe I will go ahead and create a field that is called profitable. And if I make it a bit bigger, so I'll probably write something like this, right? Let me see, make sure that it's visible. So if I create that field, profitable, bring it into the view, that's nice. That gives me some information, but that is running at a lower level of detail. So I even have some orders where the part of the data that was profitable is separated from the other one. And that's not telling me the answer that I need. So maybe I want to rewrite that formula at an aggregated level. And if I can type today. Okay, that will do for today. You'll have to bear with me. I can't type and think at the same time. So maybe this time what I want to do is to take the sum of profit and check whether that is greater than 0. And if I bring that to color, I have a somehow similar view, but I can see now it's calculated at the order level, so at the viz level of detail. It's a step closer, but it's still not giving me my answer. If I was to remove order ID from the view, now I'm getting close to where I want to be. But if I was to remove customer name out of the view, I've lost that information. And that's essentially what I want to have. So maybe if I go back a couple of steps, I want to write a level of detail expression for that. So I'll write a profitable LOD, make it very big, and it's going to be a fixed level of detail expression. I will fix it on customer name. And I want to have the sum of profit for this customer across all the data that belongs to that customer. Now if I bring this into the view, I can see that for all the orders, I have the same value for profitable LOD, which is essentially the total profitability for this customer, which is great, which is what I want. But now I just need to change it again compare it to 0 to see whether it's profitable or not. You'll see that I have an error now. Before that we had a number, and I changed the type into a Boolean. So I'll bring this into color instead. And now we have the information we were looking for. I can remove order ID. Now this still looks exactly the same as before. The difference is I can now change my view, and I'll be able to remove customer name from the view. First, what I want to do is not that, but to bring in the count distinct of customer name. So now I can see there's one customer for each of the line. And now instead of looking at it per customer, what I want to do is to look at it also based on my level of detail expression. Maybe that is more easily seen this way. So I now can very quickly see how many customers are overall profitable or not, and I do not have customer in the view. And so we have the answer to the question we had. We'll move on to look at include.
Yes, because fixed is amazing. It's really good because, as you saw, it actually runs independent of the view. It calculates whether or not that particular customer is profitable because we've specified that in that calculation. And that's a particular characteristic of the fixed calculation. It doesn't matter which dimensions you have in the view, it will just calculate it for you. Basically, the calculation will run before it even regards all the dimensions in your visualization, which allows you to do all the amazing stuff. You can even turn them into dimensions, as Benoît did. Now this is where we're going to switch it up and say, well, include is therefore, if it's a unique characteristic of fixed, include must therefore be dependent on the view, which it actually is. Because let's do the same example that Benoît used. We assume we have a vis that has segment on the level of detail, and we write an include calculation that says include customer ID, sum of sales. The resulting calculation will take into account that segment because an include is dependent on the view, so it will take into account those segments, but it will then also add that customer ID to it. So basically what we're then doing is saying, well, we're going to calculate something on a finer level than the visualization actually is. So let's bring our example with the dots back in, right? So we have a segment on our level of detail. Let's assume it has 4 marks on it. And then we run a calculation that include customer ID, which then also takes into account customer ID. Now suddenly we have more marks than we actually have on the view. So the calculation will run and we'll use these examples once again. Now where we saw fixed replicating those values, we'll see that in an include calculation, there'll be an aggregation happening. Now, as you can see bottom right of my screen, I've currently wrapped that include into an average. So if we're looking at the blue, it will just take that 7 and, or just do the red ones first. Let's do that, why not? So we'll have 2 domains, it's 7 and 3, it's an average. Total is 10 divided by 2. So we'll return a 5 on our viz. If we do that for the green, we have 2 and 0. Together is 2. Average that out, that's 1. Now we just have 1 value for the other one, but it's good to notice that you still wrap an aggregation around your include. Still that group by, but we're doing it on a finer level than the visualization level of detail. Now let's look at a business example where that could potentially be useful. So what we're going to be looking at today is, let's start looking at average customer spend. Because remember, we did the level of detail of the viz, or the data, and it was per transaction. Transactions make up an order, and a customer could have done multiple orders. So we have these 3 different levels. Now currently on the screen, you see that I have my sum of sales per year. So if I were to just change the sum of sales to an average, it would show me the average per of the data, right, which is a product. So my average product in 2016 was 291 pounds, which is not what I want if I want to, for instance, look at my overall customer spending or my average spend per customer per year, which sounds very complicated, and we don't have those values on the view. But an include, of course, is dependent on the view. So let's start looking at that. Let's look at average spend per customer. And we're going to tell Tableau, well, you already have sales and the year in the view. So why don't you just include for me the customer name and give me that sum of sales? Brilliant. So let's call that the average spend, and then we'll bring that into the view. I'll change this back to a sum so you can see that what's actually happening here is the same. We can see that, as remember when I said to you that an include will still be aggregated, we'll still have an aggregation surrounding it. Currently we'll say a sum. So it has calculated the total spend per customer and then just summed them up. The result of which is, of course, everything that we sold that year. So if I zoom out, you'll see that my two lines are actually the same. The brilliance lies in the fact that when we did average on the top line, it will just do it per product. If I now do the average on my include calculation, it will do the average per customer. So now we see our average spend per customer per each year, and I could change that to months or days or whatever I want, because include takes it all into account because it's dependent on the view. So we specify that extra level of detail even though we don't have it in the view, and that we can clearly see that that average spend is indeed increasing over time. Does that make a little bit of sense to people? Yeah? Great. So let's start moving on to the third brother in the family.
So as you can already guess, exclude is going to work in a similar way as include, just the other way around. It is also depending on the level of detail of the viz. Again, we try to keep the example consistent. If we have two dimensions in the view, segment and category, we exclude category. You already know the answer. It's going to compute minus category at the segment level. So in this case, it computes at a coarser or larger level of detail than the viz level of detail, which also means that you need to exclude something that is in the viz, otherwise it's not going to work, right? So again, if we have a visual viz level of detail, segment and category, we calculate excluding the category, so it calculates at the segment level. We'll get some values, and they will get replicated for the different elements on the viz that are part of the same segment. Before we go into order of operation, I'll switch back here and make another live example. If we're looking at a simple sum of sales by category and subcategory, and I now want to exclude subcategory to effectively have the sum of sales per category, we can create a calculation called exclude. You can start writing exclude and have the shortcut, and we want to exclude subcategory and have the sum of sales. Okay? Now, if I bring this into the view, you'll see here, and we conveniently have the total here, so you can compare the values. And what you see here is exactly the total of each category, right? That's what you would expect. Where this becomes interesting is because it is related to the level of detail of the viz, it will change as you change the level of detail of the viz as well. So if I was to bring in a filter on subcategory, let's say, and I'll start removing some of those, you'll see that value change as it changes for the view. If we'd use a fixed calculation, that value would not change. Also, if I bring in additional dimension into the view, let's say shipping mode, again, that will change then depending on what's added to the viz. So the important point here is this is all relative to the level of detail of the viz, so you can express those calculations. Okay, makes sense? Clear? These were the easy examples, and I will get into some more interesting one in a moment. But before we do that, we do need to cover the order of operation, which can impact those expressions.
Yeah. because Tableau has a particular order of operations. It runs a few of its actions whilst building that visualization. And if we're looking at the visualization pipeline, it looks a little bit like this. Now I'm going to quickly glance over this and focus on the level of detail, but there's a great order of operations hands-on session later on, and we'll have a slide where you can find that one. But we said the fixed calculation was independent of the view, and we specify those dimensions in it. And that's exactly why we find that fixed LOD right here, just the 4 dimensions. Now the top light blue, I mean I'm colorblind, but I think those are blue, extract and data source filters are filters that will just run on the data, which data you're actually bringing in. And then we've created this thing called a context filter, because there might be use cases in which you do want the fixed calculation to be impacted by one particular dimension or 2. And we're going to talk a little bit about that. And that's where we also find the include and exclude behind the dimension filter, because as we've shown, they are dependent on the viz. So first we build the dimensions into the view and then let the level of detail be dependent upon that. So sorry, I saw some pictures. Everyone got that picture? Cool. So what if you do want to filter on a fixed calculation, if you do want a fix to be impacted by one or multiple dimensions? Well, you can. And it's that context filter. For those of you who haven't done it yet, it's whenever you bring in a filter to the filter shelf, if you right-click it, there's going to be an option that says add to context. And we'll actually do that. It's not some sort of abstract meaning that you add it to context and that your cluster of something like that doesn't happen. It just moves it up into the order pipeline. So it first generates that filter, and then it will calculate that fixed. So let's look at an example why that might be, or where that might be of interest. Let's look at the, let's do a percentage of our sales for these particular categories. So I'm going to write a fixed calculation to see, well, percentage. I'm going to say, well, do me the sum of sales, and I'll just make this bigger, and then divide that to me by my fixed per category sum of sales, because I always want this to be divided by my total sum of sales within a particular category, sum of sales. And I'll just write this in a sum as well, because we can't mix aggregate and non-aggregate. There we go. I'll hit OK, and we'll have the percentage in the view here as well. And we don't, because it doesn't like that. I am missing something, Benoît.
That's always the fun of the live demo.
It's always the fun of the live demo. It always happens. Just happens to be me. We're a live recording, guys. It always happens on the live recording. Tell me, what am I missing? Yeah, which it should pick up now. I don't know. It's down. You know what? This is why we have this. There you go. So let's get our calculation out and see what I've done wrong. Oh, there it goes. Oh yeah. Sorry. I should have told you another tip, and I'm going to show it to you now. Let's bring it back. Let's go back to percentage. What I've done wrong, ladies and gentlemen, is specify that we want this calculation to run for each particular category when I don't want that. I just want this calculation to run across all of my sales in total. Very sorry about that. So if we don't, and that's actually like an important tip, if we don't specify the dimensionality within the calculation, it just runs it across the entire data set. So we don't specify dimensionality, it's just all of the data. And then there's actually another quick tip, and that's if you want to do that, you don't even have to bring the fixed in. You just say curly brackets sum of sales. That's just encaptured to me all my data in a fixed value that I want replicated across my entire data set. And now my values are correct. Thanks for bearing with me, guys. I'll just make sure that these are actually percentages so we can see that these are percentages. Now when I start taking out the central, we'll just see that we're now looking at a percentage for just the south value. And I've said do it across the entire data set. So Tableau has taken that 210 and divides it by whatever the total was earlier. But what if I do not want that? What if I want to look at those categories for that particular region that I'm selecting? And that's where the add to context comes in. So if I then move that filter up in the calculation, so the filter that I'm using there, the region, the moment I move that up to context, we calculate that first. It then becomes part of that fixed calculation. And you'll also see that the 20.15% total there will change to 100 because now your fixed is impacted by that context filter. So sometimes you do want it because in that particular use case, you still want people to interact with the regions or whatever dashboard or use case you have personally, but you still need that fixed calculation for that value to be replicated. Everyone clear? Cool. So let's just start moving into some examples which you might use in your day-to-day life. So one of the things that we see a bunch of our customers using is a cohort analysis. Now I'll explain a cohort a little bit. You just define a group of people that are part of a particular cohort. Now one of the use cases in which you would potentially do that is by looking at when did my customers become a customer of mine and did I retain them over time. So in this particular example, I have four cohorts. I have 2015 all the way to 2018. And customers can onboard us at all time. But what if I now want to see that proportion of sales within each year from which cohort that person was from. So in 2018, how much of that revenue was generated from customers that have been a customer with me since 2015? Sounds complicated, right? Here's where LODs come in. Because LODs can be an aggregation, but they can be anything. And a fixed can be that dimension, right? It's independent of the view. So we can write an LOD, and let's call it a cohort now. So we'll write that fixed calculation again, and we're saying, well, for each customer, Tableau, please return to me the minimal value for that customer's order date. So what this calculation will now return is the minimal order date for each customer. Now that first screen where we showed fixed will replicate that value, right? So if I were to show those details first, did I have cohort in here? Just quickly run it here as well. Fixed. There it is. And if I get this value in, and you'll see the replication happening, and this is an amazing trick because we all have that error message, right, where you say cannot mix non-aggregates and aggregates. LODs can take that away for you because we're replicating that value across the entire data set. So you can start using those aggregates on row level calculations, or on different level calculations. And that's what you see happening here. That cohort analysis for, let's say, Alan Shonley, is even though we had a bunch of orders, it will replicate that value the 26th of January 2015 because that was Alan's first purchase with us. So how do we then bring that into that cohort example I showed? Very easy. We'll grab that cohort, drop it onto color, and we're done. Remember, we run those dimensions later on, we get those values, we run Tableau as Tableau is being run. It just aggregates it up to year, use it as a dimension, and we can see that 2015 obviously is just that blue cohort, which is cohort 2015. We'll add orange in 2016, and we'll see that in 2018 most of my business is still done by those customers that started in 2015, but we have a little bit of a difficulty bringing in new customers. Can't even get my mouse to be on it. I think it's only like 4K here of new customers that we've acquired in 2018. So just a quick way in which you can use that simple interface of a level of detail calculation but derive a lot of information. We're good at retaining our customers, but we might want to add some new ones. Just from the fixed per customer minimal order date. little bit of sense to everyone? Great. So let's start looking at proportion of sales, and I always like this one. We've already looked at those percentages a little bit, and we all know that fixed is not impacted by that total, right? So we can look at, for instance, we have that sum of sales, and I can tell Tableau total sales to please give me fixed for each category the sum of sales. If you didn't know this one yet, you can always get a pill and just drag it in if you want to be even quicker. So just fix for me that category sum of sales. So whatever that will happen if I bring this into the view, even though I might filter out some regions, my values, and I'll put the labels on here so everyone can see, remain unused, unchanged in that fixed calculation, right? So this is always a trick that I like to use in my dashboards. You can then put a dual axis on this, and if you make sure that those are synchronized, turn them into a bar, and this is a trick that we call proportional brushing, is you can take those values out, and it seems like you have a depleting bar of your sales. Because once again, your fixed is unimpacted. That will always show that total sum of sales, but your red overlaying bar will only show you that for that particular region that you've selected. Always like this, if you want that little sort of hacky trickery in your dashboards, you can just quickly use a fix to take care of that for you.
Excellent, thanks Erwin. Let's look at a few more examples, and then the good news is I think we'll have quite a bit of time for Q&As, so then we can take some of your examples and see if we can illustrate it live. This example, in this case I'm looking at each of the customers, and I want to understand how much business have we done with each of those customers, so I can rank them. So you can see it here. I have my list of customers, and I might want to target the customers with whom we've made most business. But what I'm interested in is actually to create groups of those. How can I group them based on the total spend that they have? And again, same challenge, I may not want to have the customer name in the view, so I want to have an LOD for this. So I'll create that. I will call that my customer total spend. And you've guessed it already, it's going to be fixed on customer name and the sum of sales. Okay? Now that I have this, if I bring it into the view, you can see that it's exactly the same as what I can create in the view, but I can have access to this outside of this view. What I'm interested to do now is, if I can bring it back, what did I call it? Customer total spend. So I want to create a bin of that measure. So I'm going to create groups, brackets, for the values of the total spend of customers, so I can put them in those different brackets. So I can see the ones who spend a lot of money, the ones who have not spent yet a lot of money with us, and I can look at it this way. Maybe I want to look at it as bins of £1,000, and then I want to bring this into the view instead of each individual customer. Because this is close to a distribution, it's probably more familiar to look at it in a vertical way. Now I can see this is all the business that I've done for customers that I haven't spent £1,000 yet, below £1,000. I don't really, this is an interesting information, how much business did I do for that bracket, but what I'm more interested to know is to know how many customers, and again, you need to bear with me, that's not it. This one is the one that I cannot get right. There we go. I want to just count how many customers are part of each of these brackets based on their total spend. Okay? So now I have this nice distribution. I know that where I have the most customer is they spend between £1,000 and £2,000. I have some customers, few customers that really did a lot of business, so maybe I want to target those ones for certain purpose. And maybe what I can also do is to bring in profit into the view. So now I understand, for instance, that although I do have a few customers that spent a lot of money with us, they may not be the most profitable one. And if I wanted to target a segment of customers where we are particularly profitable, I'd look at customers who have spent historically between 3 to 7K, and maybe I can send them promotions or try to bring those back in the store. Okay? So let's look at another example. If I'm looking at sales per country over an entire region, and let's take the UK for instance, so that will give me my percentage of sales for the UK, right? Just below 18%. But as I filter down, if I remove some of the countries and I look at it, now my percentage is relative to what is filtered in the view. So great, this means 70% of that group of countries is coming from the UK. But what if I wanted to keep that information about what's the absolute contribution of the UK within Europe, and I still want to have it in that view, right? So I can do this with a fixed LOD, of course. So we're going to call this country contribution. And what I want to know is, again, the total sales per country. And I want to divide that by everything, but in an absolute way. So as you remember, we have that trick. I can use the curly brackets. And I want the sum of sales. So this will give me the total sales per country. It's fixed, independent from the view. And this will give me the absolute total sales on the data set. So nothing is going to influence that calculation. It's always going to give me the country proportion. Now that I have this, I might want to bring it into the tooltip. And if I look here, probably want to format it. As a percentage. And now I can see again my just below 18%, yeah, independently of all the filters. So that's a nice trick. Again, the curly bracket is an easy way to have that absolute percentage. So that can come in really handy for calculating percentage very quickly. One more example that I want to show you is you can actually nest LOD calculation within an LOD. So if you want to go further, if you want to go more detailed calculation, and let's take a look at this example. So, excuse me. In this example, I want to compare a smaller area within a country. I want to calculate the average order value for that area, and I want to compare that to the national average, right? But in the view, the level of detail of this view is finer than the one that I want. So how can we do this? Here we see, for instance, some of the areas, and I can never pronounce that, so if there's anybody from Austria in the room, please forgive me. So Carinthia. I can see that my average order value in this area is 5 times the national average. So that might be very interesting for me to know, to identify where are these. So how can I calculate this? I have here, now let me make it bigger so that it is readable. So we're talking about sum of sales, and first I want to calculate it for each order ID within a country. So that will calculate within each of the country what is the total sale per order. And then I'll take the average of this, which will give me the average order sale, and then I want to bring it at the country level, right? And then the aggregation here is because we need an aggregation. I could have used anything else. Now, what's interesting is when you are using nested LOD calculation, I can actually rewrite this. Now I've specified it in a very, very precise manner, but I could also call this, I could also use include order ID instead. It will inherit the country because it's part of a larger LOD. So if I just write it this way, I should still have the same result, right? So that's just a little bit simpler way of writing that LOD. We started a bit early. We have 15 minutes for Q&A. We'll spare a few minutes to wrap up towards the end. But now the floor is yours. If you have some questions, please ask us. We'll try to demonstrate live.
We'll summarize and recap a little later on, but this will be a good time indeed for us to. I'm sure you've held on to quite a bit of questions, so there's one.
You have the portable mic, so maybe you can...
I don't, but we'll repeat it, yeah. Yeah.
Yeah, you can, but in the...
Can you repeat the question?
Oh, sorry,
Just
yeah.
so we can
So
look here.
you calculate those averages and those fixed calculations in your calculations, but then more specifically in this particular example, could you then also determine what the difference or the percentage is Germany versus France? Any other one, yeah, but specify those values that you want to compare with each other.
Yes. So I'll take this one.
Yeah.
Maybe the easiest way to do this is to use parameters. So we've shied away from using too many other topics in this session because we wanted to really concentrate on LODs. But you could have a parameter that say choose a country of your choice that you want to calculate that on. You could use this then in a fixed calculation that calculate on this. You could also use a if statement to say if the country is Germany or whichever the parameter value is, then take the sales, otherwise take 0, and then calculate that up. And then you'll have your absolute value for the country that's selected, and it changes as you use the parameter. So you can combine parameters with LODs. There's another session that discusses when should you use table calculations. We'll give you also a lot of options for percentages compared to LODs. So it's good to understand when you would want to use which one, but you would have a lot of options. For this particular question, I would go use parameters for this.
Yeah, but the LOD versus table calcs one is actually a really good one. Because we know if you're familiar with table calculations, they run based on the values in the view. So I'm already thinking a cross table where you just put color, have your fixed calculations on it, and then run a table calc across that. So you always have all the values in there. They are still dependent on the view, but that session is definitely one I think that will be a good way to get even more, some more depth in that. Yeah, definitely.
Great question. Any other questions?
Don't be shy. Yeah, good. Okay. Yeah. Yeah. Yeah, so if I have to, I'll repeat it quick for the recording, or for those who haven't heard. You're specifically asking that the use case is project management, so, or any other, or just in general? Yeah. 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 Okay. Yeah. It's a pretty specific question. That's fine. I think if I roll it back to what LODs can do for you, the main topic, I hope to take this away from the session as well, LODs can contain whatever you want. So they can be their replicated value that you needed returning. Now their replicated value can be anything. And Benoît's already mentioned this. We can use parameters, or the aggregation in the LOD can be as hairy or as complex as you want. So if you want to write an if statement, so if the date diff between those 2 points, if that happened, if you want that whole if statement in there, you can put it in. I've seen in one of our customers fixed calculations that were 200 rows deep. I mean, and they had 4 nestings in there and it still worked. If they work from the inside out, that's also important. But if you run, you can put anything in there as long as the result of it is an aggregation. But that aggregation can be as deep as you want in project management, on a project level, on a customer level, or whatever you want that to be. So use all the other features that are also in Tableau, writing those if-then statements, using parameters, and then you can always put that in an LOD if you want that replicated, because that's what you want, because you can then test that against the values that you want to test that against.
So maybe something I can add to this. So that the problem, the challenge you have is basically you do not have data. So even if you write an LOD, if there's no data for a particular month, you won't have any value there, right? So the 2 things that you might think of. One is you could cheat by creating the data that's missing. So let's say another data set with a value, random value for each of the months, and then try to combine it. So at least there is data. There won't be any numerical data, but there is something that materializes those gaps, right, in terms of time. And then the second tip that's maybe more useful for you is we're running Tableau doctor sessions during the whole conference. So I'd invite you to see if you can walk in with that particular example and see if we can help you specifically on that example and see how far we can get.
Yeah, get a session with Luca. He'll help you out instantly. That would be my personal tip. No, but yeah, definitely do that. But just, I think the basics of the LOD are there, right? You can do it on any dimension. It'll be replicated. You can do anything, but absolutely anything in that measurement, in that aggregation, as long as it's an aggregation. But you can set the dimensions and all that. That can be an if statement. If you miss the data, you can use a scaffolding table to fill all that up. You can do whatever you can, definitely. It's a little too specific, I guess, to answer the whole question now, but there are ways to do that.
Okay, maybe one more question?
Yeah?
Second? It's a great question. I'm not entirely sure, so I can't answer on the spot. Best way to try, best way is to try it. So
What Windows calculations?
yeah, Windows sum.
Oh, got it. No. And that is back. Can you get me to the presentation? Because a Windows sum is a table calculation, but definitely go to table calcs versus LODs. You'll get your question at that session. Selçuk will run it. But I'll go back here. This is where we run the window calc. So that's where the window average is being run. It's a table calculation, and therefore it's a table calc filter. So you'll see that everything between measure filters and on the table calc, that's where a window sum will run. So a window sum is per definition dependent on the view. It's even dependent on the values that we have in the view. So if you use a running sum, for instance, if you've ever used the table calculations, what Tableau actually does, it will generate the normal sums first and then start adding the previous value to the next one. So it's all down to that order of operations, but specifically this question, go to Selçuk's one. I think it's tomorrow, but that might be a good way for us, I think we're on time anyway, to start wrapping that up and say what we've done today, and then I'll have a slide when Selçuk's running that as well. Hopefully, at least at the end of this session, we'll have seen that LODs can vastly broaden the opportunities that you have in your calculation tool chest in Tableau. Take away that those fixed calculations can be used as dimensions. They're independent of the view, whether you want to use it as bins, whether you want to calculate or count your number of users. They are very fixed, are extremely valuable because they are independent of the view. in an exclude are dependent of the view, but therefore give you a lot more flexibility when you're talking about, for instance, people interacting with a particular dashboard. So always also take a look at the use cases that you want to use those calculations for, what might be best to use. And then just as a final tip, you can definitely shorthand write that fix by just using the curly brackets, or just don't specify the dimension if you want to. We hope at least that you feel that you have a little bit of understanding on how LODs work and what they do. We do want to say, hopefully you're not afraid. Just get your fingers in the mud, get started. You all got this at this point. So just start, get calculating. If you want to go to that table calc versus LOD, it's tomorrow at 10:30. Sorry, I didn't know from the top of my head, but that's where they'll be run tomorrow. Tomorrow morning, that's absolutely great. That order of operations hands-on session, if you want to understand that, that's currently running, or it's currently wrapping up. There won't be a recording of that one because it's a hands-on, but you will have access to all the slides and the materials after the session. So if you want to know more about where to run these things and how that impacts your view, make sure that you look at that material when it becomes available to you. And with that, we'll linger around if there are any more questions. This always is the mandatory slide, but please give us feedback. I won't do the general mistake, joke that we want 5s, because we don't. We actually want to hear from you what you thought of this session. We're always trying to improve it. Hopefully it met your expectations. We work hard on it, so we also take that great care into reading your feedback. And with that, it's thank you from us, I guess.
Yeah, thank you, everybody.